Hey everyone, so we're going to practice a question on percentage yield, but if you're a grammarian who's just concerned about the 10th grade mock examination, then jump to 234. So let's begin the question. It says, in an experiment, 220 grams of carbon dioxide and an excess of hydrogen are reacted in a sealed container until an equilibrium is established. I have the equation ready with me. It says a mass of 46 grams of methane is produced. So this is the mass of the product that I have with me, and methane is right there in the equation. It says calculate the mass of methane that should have been made if the percentage yield was 100%. Now 100% yield is a hypothetical concept. You can never have 100% yield. So that's theoretical yield actually, and something that hints us that we need to find theoretical yield. So moles of carbon dioxide is something that we find in the first place because we have the data for it. MR for carbon dioxide is 44, so 220 divided by 44 is going to be 5 mole carbon dioxide. We apply a ratio between carbon dioxide and methane because carbon dioxide has been given to us, methane has been asked. So 1:1 ratio between them. So carbon dioxide and methane have a ratio of 1:1, which means 5 moles of carbon dioxide could give us 5 mole methane. We need to find the mass of methane, so we know the mass is equal to moles times molecular mass. For methane, the molecular mass is going to be 1 carbon plus 4 times hydrogen, which means 12 plus 4. So it becomes 16. So obviously, carbon is 12 by atomic mass and then hydrogens were 4, so it becomes 16. 5 times 16 is going to be 80 units of theoretical yield. So the mass of methane that I can obtain theoretically is going to be 80 grams. But the next part says calculate the percentage yield. So we have the actual yield with us, which is 46 gram methane. Percentage yield is going to be actual divided by theoretical. Actual has been highlighted for you with a green pen. It is 46 divided by 80. 80 was theoretical yield times 100. So 46 divided by 80 times 100 becomes 57.5%. Actual yield was given, theoretical we found out. So this is how we do percentage yield questions. Now let's study a new concept, that is empirical and molecular formula. Let's find the difference between them. So what is empirical formula first? Empirical formula shows the simplest ratio between the elements in a chemical formula. So it shows the simplest ratio between all the elements which are present in the chemical formula. On the other hand, molecular formula is something more complicated because molecular formula shows the actual ratio between the elements. So it's not concerned with the simplest ratio. It shows the actual number, or you can say the actual ratio between the combining elements in the chemical formula. So molecular formula is likely to be bigger, and empirical, which is the simplest ratio, a little smaller, more simpler. For example, if I give you few molecular formulae, and if I ask you that to find the empirical formula, let's try out. We have C6H12O6. So 6, 12, and again 6 can be simplified through a ratio of 6, and it becomes 1:1. So the empirical formula of C6H12O6 becomes CH2O. It's a simpler ratio. In the second one, Na2S2O6, 2 to 6 can be simplified as 1:3. So it becomes NaSO3. So empirical formula is NaSO3. In the third one, Ca2SiO4 cannot be simplified any further because actually they are the simplest ratio. Silicon is already 1. You can't make it any more simpler. So over here, empirical formula is going to be same as the molecular formula because Si is already 1. You can't make it even more simpler. Like in the last one, MgCl2O5, these numbers can't be simplified because they don't come in a common multiple. They don't have a common factor. So they can't be simplified. You can't pick a number and divide 2 and 5 by the same number. So remember that molecular formula can be sometimes same as the empirical formula or sometimes rather bigger than the empirical formula. So molecular formula is sometimes same as the empirical one or bigger than the empirical one, but molecular formula will never be smaller than the empirical one. Empirical is the simpler one, molecular formula is the bigger one. I have the steps with me to calculate the empirical formula of any compound using the percentage composition. So when we talk about using the empirical formula, we have these steps over here. That it's a chemical formula that talks about the simplest ratio. If we have the percentage of elements given with us, what do we do to find the empirical formula? First, we divide the percentage composition by the atomic masses. Atomic masses do not mean the diatomic molecular mass. Once we have divided them, we have the ratios with us, we identify the smallest ratio between the elements. And once we have the smallest ratio, we divide all the ratios by that simplest number. So it's just 3 steps. These final values are going to be the empirical formula, unless we have a value with a 0.333 something. So if we have a ratio with 0.33 or 1.33, we multiply all the values. Why did I add like? Just a second. Yeah. We multiply all these values by 3. So if we have a 0.33 ending, we multiply all the values by a 3. And if there's a ratio which is ending at 0.5, if we have any value ending at 0.5, we multiply all the values by a 2. So let's try a question. Let's get done with the practice. We have a question where we have 60.0% sulfur and 40.0% oxygen in a compound, and I'm concerned with the empirical formula. So we have sulfur and we have oxygen. Sulfur is 60.0% and oxygen is 40.0%. So sulfur should be divided by 32 and oxygen should be divided by 16 because these are the atomic masses. When we do that, we have sulfur giving us a ratio of 1.875 and oxygen giving us 2.5. 1.875 is a little smaller, so we divide both these values individually by 1.875. So 1.875 here, and again 2.5 divided by 1.875. Obviously sulfur gives us a value of 1 and oxygen gives us a value of 1.333. So let me write that. Oxygen gives us a value of 1.333. We can't write oxygen as like 1.3. So we multiply both the values by a 3. Sulfur becomes 3 because 1 times 3 is 3. And oxygen becomes 4. So 1.33 times 3 is 4. So the empirical formula becomes S3O4. This is the empirical formula with us. Let's try one more practice question. It says a compound is found to contain 23.3% magnesium, 30.7% sulfur, and 46.0% oxygen. So magnesium has an atomic mass of 24, sulfur had an atomic mass of 32, and oxygen has an atomic mass of 16 units. Now, magnesium 23.3 should be divided by 24. Sulfur's 30.7% should be divided by 32. And the percentage of oxygen, which is 46, should be divided by 16. This is the first step that we do. We don't do any calculation any simpler by dividing by 100 or stuff. Just divide by atomic mass. That's your first step. 0.970 for magnesium, 0.959 for sulfur, and it's going to be a little bigger. I believe it's 46.0 divided by 16, 2.875. Let me write that. Now, which one is the smallest? 0.959 is the smallest. So we divide all these values by 0.959. 0.970 divided by 0.959, 0.959 divided by 0.959, and 2.875 divided by 0.959. In the first one, it's almost 0.99. That's almost 1, right? We don't have to show it. It's already 1. Again, same 1 for sulfur. And in the case of oxygen, it turns out to be 2.99, which is obviously 3, which is virtually 3. So magnesium becomes 1, sulfur is already 1, oxygen becomes 3. So the empirical formula is MgSO3. This is the empirical formula. So this is how we get it done. Thank you guys.